I will demonstrate how to easily perform precise pulse measurements using the Rohde Schwarz FSH handheld spectrum analyzer or the ZVH cable and antenna analyzer along with the wideband power sensor. In this example, I'm using an SMBV 100A signal generator in order to create a pulse signal that has a pulse width of 1 microsecond and a pulse period of 100 microseconds. After I've connected my wideband power sensor to the analyzer, I can now change to power meter mode. This mode without a power sensor is not as precise, but I can connect any NRP power sensor and take advantage of the increased precision. If I connect one of our wideband power sensors, I also have the added option of looking at power versus time. Our wideband power sensors have resolutions down to 50 nanoseconds and can look at frequencies up to 44 gigahertz. I'll select the appropriate frequency of 1 gigahertz in this case, and let me just reduce my sweep time. You can see how the instrument automatically starts calculating the pulse parameters, things like pulse width, pulse period, rise, fall time, etc. If I'd like to have a more consistent measurement, I can then choose to activate the trigger, and I'll just add a short negative delay so that I measure the first pulse appropriately. If I wish to zoom in on the first pulse, I can further reduce my trace time. And we can very easily look at the characteristics of the pulse amplitude. Notice how at the top here, it still calculates my pulse width, rise and fall time, but it doesn't provide pulse period or pulse separation because I'm only looking at one pulse. All of this I've done without having to use any markers, but if I wish, I can activate a marker and look at a particular point along the trace. The combination of precise pulse measurements and a rugged handheld RF analyzer like the FSH or the ZVH is very useful for maintenance and troubleshooting of radar systems, especially in outdoor remote locations. For more information, please visit our website at rohdeschwarz.com.